understand fundamental of ISS protocol. Before that, we are going to learn protocol history. So protocol history means when first dynamic protocol was RIP, 100% classful. So Cisco convert RIP into version 2, supports VLSM authentication summarization, that was good. After that, Cisco developed one protocol that is called IGRP, Interior Gateway Routing Protocol, which supports 100 router because RIP supports only 15 router. So this 100 router works only in class full domain, not classless. It's not possible to have 100 router in class full part. So then two lobby comes into picture. One was American lobby, another was European lobby. So American lobby developed protocol OSPF and European lobby develops protocol ISIS. That was there. And after that, Cisco convert, and then this comes under interior gateway protocol. Then EGP comes into picture, that fails to come onto expectation. So they have convert EGP into BGP, and Cisco convert after that IGRP into EIGRP. That's fine. After that, now we will concentrate here. OSPF and ISIS. Why ISPs prefer ISIS instead of OSPF protocol? That we need to understand properly. Both are link state protocol. Both uses same Dijkstra algorithm. But thing is that ISIS is only protocol which is hexadecimal based and it uses layer 2 header without joining multicast group, without using network command. It provides more fast convergence if you will compare with the OSPF. All right. So if it is used, now it is using only layer 2 header. Layer 2 header means it is more secure instead of part which is using layer 3. Now understand one thing. Either it is RIP version 2, OSPF, EIGRP and BGP. This is actually developed by TCP model or DoD model, what the name you want to say, doesn't matter. So your TCP and DoD model is binary based, remember, and OSI layer is hexa based. We develop one protocol that is ISIS, it is also hexadecimal. This one is. Based upon that, it helps like RIP, EIGRP, BGP. I will not take the name of OSPF because it never comes under address family. In MPLS part, we will learn. So it is hexa based, so it helps other protocol to work. Now, both OSPF and ISIS. In service provider network, ISP network is called POP, point of presence. There we have three set of router, PE router, then customer edge router and provider router. Between PE router to PE router, we are running IGP, and mostly only two protocol, either OSPF or ISIS. Because in MPLS we will come to know how MPLS helps to make ISP score BGP free. So these two protocols, OSPF and ISIS, both these two protocols support IP and numbered link. Means if I want to create unidirectional tunnel, right now we have completed the part of BPN, DMBPN, correct? So tunnel need to end, both end we need to have tunnel. So in MPLS part, we have one thing that is called traffic engineering. And there we doesn't require bidirectional tunnel, that is called unidirectional tunnel. So both OSPF and ISIS protocols support IP and numbered link. That's why not only here, in the hardcore data center environment, when we want to configure VXLAN, VPC, that part, VXLAN along with VPC, multi-site VPC, In super spine, we have only option to configure the OSPF ISIS because they are 4, 5, 6, 7, 8 link mapped with one loopback address. That's why they support this particular. OSPF uses IP protocol number 89. Uses layer 3 header, correct? OSPF consists packets and form neighborship joining multicast group 224.0.0.5. ISIS doesn't join multicast group. In OSPF, what we have, suppose a router having, you can say, 4 interfaces. If router consists 4 interface, if you want to have this type of connectivity on 2 interface, we can have one process ID, another interface, we can have one process ID. Another thing, if at a time 2 and 3 process IDs running, OSPF will not give you error message. But ISIS protocol uses NSEP address, Network Service Access Point address, which remains common for one router, unique for one router. Like in BGP, we can have only one instance of AS number. Multiple instance of AS number is not going to work. Remember, it will give you error message. We will understand this particular part. So see, in OSPF.
Yeah.
Yeah, tell me, any question? Anyone having any query? In OSPF, we are using router and we are using host. User part is host, that network part we have router. In ISIS protocol, routers are called end system and users are called intermediate. Router are called intermediate system and users are called edge system. Now, in OSPF, we have hello packet. In ISIS, instead of hello packet, we have intermediate to intermediate hello, which uses protocol data unit layer 2 header. OSPF works on area concept, correct? OSPF works on area concept. ISIS doesn't works on area concept. ISIS works on level concept. In ISIS, we have level 1 router, we have level 1, 2 router, and we have level 3 router. Sorry, level 2 router. In OSPF, we have backbone area. All areas need to have link with OSPF, backbone area. In ISIS, backbone area part is the level 2. Here you can say that is the level 2. Area is the optional section under OSP ISIS code. Okay, sorry, I have mentioned wrong, 224. What is there? 224 multicast, yes, 224 0.5 actually it is using, not 6. So once you want to discuss OSPF multicast now, 224.05, reason behind. In production environment, we are working only for, this is not L3 header, this is for multicast. We are working on point-to-point network. There we doesn't have DR. If you will try to capture, you will get only 0.5, not 0.6 anywhere. On interface part different, but that part is there. In ISIS protocol, we doesn't require network command. It need to initialize directly under interface mode. We have already completed ISIS IPv6 part. In IPv6, what the protocol we want to configure doesn't matter. For IGP part, interior gateway protocol, there also we doesn't require network command. Okay, same that they have copied that particular part from ISIS protocol. So why ISPs prefer ISIS over OSPF? Because OSPF is very rigid. Rigid means OSPF is going to prefer first own area route, that is intra-area route O, then different area route OIA, then it will pay for OE1, then it will pay for OE2. This is the strict design. Though in the production environment we are not using, you can say, multi-area, but yes, there we need to use SAM link. That is the requirement. We have domain ID, we have downstream bit. So multiple complexity we have under OSPF to handle. ISIS is very simple. Using layer 2 header, it doesn't require any router ID. It uses layer 2 header. Based upon the MAC, it provides fast convergence. What the CADR we are assigning on router's interface, automatically it's shared with the neighbor. Other protocol like EIGRP, and also when we want to enable cryptographic algorithm, this was actually developed first by ISIS protocol. So all protocol, what the features we are using now, that actually being copied from the ISIS protocol. So now, this is the hardcore network where ISIS protocol works. So ISIS protocol work in service provider domain, in data center, and in DNAC, that is SD access. In data center, in EPIC part, controller ACI, where we have the EPIC controller, without ISIS it will not work. In DNAC, once we want to enable layer 3 link to do the LAN automation part, there we also required only one protocol option is there, that is ISIS. ISP uses ISIS. Based upon the ISIS protocol, maybe you heard the name location ID separation protocol. Very old protocol. Doesn't we want to have all route information in the router's table? We want one route locator. Without having route, they are creating tunnel automatically, mapping the part, and then we are getting the fast convergence. So multiple features supported by ISIS protocol. If you want to know from my side that ISPs now, you can say 95% we are using ISIS protocol, 5% only we required OSPF. So what thing we required, remember in the ISIS protocol first. As we know, I think you are aware with the part, ISP uses three set of this IS XR part, that is integrated service router, core service router, aggregate service router. So in integrated service router, by default, level 1, 2 remains enabled. On CSR and SR, by default, level 2 remains enabled. Level 1, I will show you in production environment, not working on the level 1. In ISIS protocol, level 1 consists only level 1 database. Level 2 consists only level 2 database. So we can't design a network where a router, one part in level 1, one part in level 2, they will not form the neighbors. If we want to have this type of network, then we require type of ABR which shares other areas information with 0 via 0 forwarded towards the different area. So we require level 1 to run. So level 1 is the theoretical concept. Another thing, like OSPF works on to reduce routing overhead, we required OSPF areas, stub, totally stub, NSSA, and SSA totally. Goal is that with the help of default route, we can have the connectivity via ABR. That's the only thing we have in OSPF. In ISIS protocol, level 1 automatically receive default route without having any extra configuration. So that flexibility we have. So ISIS is 100% level based. Now, it is hexadecimal based and not joining any multicast group. Doesn't have any packet formation what we have in the OSPF in the IGRP part, that's the different thing. So ISIS first fundamental is level. Another fundamental is network service access point and SAP address. First is authority format identifier. Then we have area ID After that, we have system ID, and then we have N selector, which always remains 0. So authoritative format identifier in the ISS part, what we require. Right now we are using 4.9. Some part previously it was used as a 4.7. So right now we required only 4.9. Based upon that, we are initializing access process. I mentioned earlier, ANSUP address represent responsible for entire router. Only one ANSUP address we can assign to one router, not multiple. Like EIGRP 100, EIGRP 200, 3, 4, 5, and number of instance we have the option. Same in OSPF. Though by mistake, if we are running, we will not get any error message. In ISAP, entire router represent through one identity that is called network service access point, where N selector remains 00. Based upon that, it is going to gather your MAC address information. We are getting fast convergence, secure convergence. If anything is layer 2 now, it's not easy to have. All right. And how to configure this part, it is also very simple. Configuration required, very simple thing, very simple steps are there. I've already shared document, rest of the part you will read there. So, see here. This is my 15.2 onwards means type of ISR image. So level 1 I will show you, level 2 you will get, level 1, 2 you will not get because 15.0 onwards by default level 1, 2 remains enabled. In all router now, already IP version 4 and IP version 6 I have configured. I will show you how to configure ISS both in IP version 4, IP version 6. What all things we need to consider. We have the option. Once you will initialize ISS protocol globally, then we have the option to force all interface comes under one label. Otherwise, if I want this in the level 2, this part in the level 1, then we have the use command under interface configuration mode. We can use circuit type. So I will show you all the options. But what you required, if you know how to initialize and establish neighborship between ISS protocol in IP version 4, in IP version 6, if you will have this step now, nobody likes you more than that, because in the production environment, ISS type is not there by default, level 2 remains enabled. Interface automatically it comes under. I will show you basic configuration, authentication, summarization, then IP version 6 configuration. I have started recording now. Let me check this part. So this recording is there. So see, I'm going to show you on every router now. If you will check here, show run interface, we have F00, IP version 4, IP version 6. Then we have F01 and F1/0 and loop back. So IP version 4, IP version 6 addresses configured everywhere. So now let's learn how to configure ISS protocol. So this part, everywhere we have level 2, and this part we have level 1. Now I have configured two areas, 0, 1, 2, 3, 4 for level 1, 0, 2, 5, 6. Level 2 is the only type of backbone which establishes neighborship connectivity synchronization between two different areas. If you do not know how to use the system ID, one moment, then your loopback address can be configured as ANSUP address. Yeah. Anyone having any question here? Tell me.
Yes, and to like work as a ASBR, right?
No, no, no. L2 is not ASBR. L2 is your backbone area, G.
Backbone. Okay, backbone ASBR. Okay, sir.
Level 1, level 2, you can say the ABR.
ABR.
and L1 is normal router, and now ASPR, what you have in the OSPF now here this is NEIS. A
NAS.
router which is going to distribute OSPF, EIGRP, BGP into ISS, it will case as NEIS. It is not ASPR term is not there. See, area is optional. So Rahul, ISS protocol doesn't use DR. Now, tell me in the OSPF, does DR have any significance if I'm using point to point? No DR required. What is
Okay.
DDR? Nothing. It remains as a slave. And if DR is there, it means here to here my network is 12.0. If its loopback is 10.1, its loopback is 10.2, network type broadcast, only it will participate, it will not participate. That's why production environment, we are using IPOS network point to point. So all interfaces are going to participate. So there is no DR required. So that type of theoretical concept we have in OSPF, which creates lots of complexity. ISS is very simple. It doesn't have any DR concept.
Okay.
That's why ISPACE and IS lobbies is very straightforward lobby. If ISP requires something, still they are ready to adopt the changes. They are providing them the new features. OSPF lobby is very rigid. Once IP version 6 comes into picture, RIP, EIGRP, BGP, adopted all at this family. OSPF lobby, you have already gone through that part. Multiple LSS we have in IPv6 that way is not present in IP version 4. So they have created separate parameter for every address family. So SPF lobby is very rigid. And ISIS lobby, European part, they are very flexible. If you require something, now they are ready to do the research work and providing the new features. That's why ISPs prefer this particular. So see, here what we required, we need to run command router ISIS. Once you will put question mark, it says ISO routing area tag. If you will enter any name, then within an area that name to be common. So it's create lots of issues. Sometimes some iOS doesn't understand this tag, so neighborship is not going to form. So what we require, just press enter. Now we have, see, we don't have any network command here. And it is called network entity title. It is network entity title. So you will write in this way. I'm going to show you. Router ISIS, NET, and this is the number. Authoritative format identifier, this two number, any number we have to use, only we are using 49. Here you can write anything, doesn't matter. Sometime it will accept, sometime it will not accept. In the
So in production, we use 49 or other number.
only 49. And previously 47 was there, Rahul. Now we are using only 49, no
So,
47.
so it is the standard for
It
the
is the
ISS as well.
yes, yes. ISIS standard is 49. Now, Rahul, this part, your area part. I will mention here 0, 1, 2, 3, 4. After that, till here we have system ID. If you want, we can use our loopback IP here, that's why router name. And then it is the end selector always 0. It means based upon that, it is going to gather routers interface connected toward neighbor as a MAC address. Based upon that, it is going to form the neighborship this way. 49. Then we have decided 0, 1, 3, 4. Abdul, I will configure access on everywhere. Router 1, router 2, router 3, 4, 5, 6. So what is this in the product diagram now? Between router 1 and router 2, here we have only level 2. Here level 1, level 1, level 1, level 2. How we are going to establish connectivity, that we need to learn. Okay, everywhere we have to configure access protocol. So see here in this way. 490123 4, then I will use 4 times 0 I will use 4 times 0. I will use 3 times 0, 1, 0, 0. And then IS type. And now you can see very typical part here. What the typical part? Understand. It says level 1. Level 1 to level 2 only. Everyone inform ISS lobby. Why not level 1 only also? Why only level 2 only? Like when Cisco developed VTP now, everyone suggested already we have trunking protocol ISL and W1Q. So just known you for VTP, you say VMP VLAN management protocol. Cisco become rigid. ISS lobby also says no, I will use only. So why not level 2 only? So something very typical we will find in our ISS part, like virtual LAN trunking protocol. What do you mean by virtual LAN trunking protocol? We have already two trunking protocols. It only manages and share VLAN consistency information. Right now, Cisco is not preferring that part. Non-Cisco doesn't have this part. So they suggested use virtual LAN management protocol, but Cisco says no, I will use VTP. Same ISS log. Level 1 and level 1, 2, part good. So why level 2 only? Why not level 2? Nothing. We can't do anything. So something very typical you will find in every protocol. If I will decide level here, routers all interface automatically comes under here. Otherwise, if you want individually, then we have command circuit type. I will show you. ISS type, level 1 and 2. Now, that's all we require. Now see one thing. History command says I have run command router ISS and SEP address and then ISS type level 1. If you will see here, so run section ISS, you will not find level 1, 2 there. Why? Because 15.0 onwards image type of ISR, their level 1, 2 remains enabled by default. If you will not configure this part now, automatically level 1, 2 will comes into picture. Same thing. If you will work on CSR router, if you will work on ASR router, core service router, aggregate service router, by default level 2 remains enabled. Like in the production part where OSPF is running in ISP domain between PE to P router, we are running only area 0, no multiple area. So these are the things. So now interface range F00-1, F1/0 and loop back. What command? IP router ISS. That's all. No network command is required. Network command required one. What is the, okay, Rahul, tell me, in OSPF, okay, in protocol OSPF, in protocol, like you can say EIGRP, or previously it was in the reversion 2. Command syntax was network and network in the only network, here network along with the subnet marks and wildcard. So what is
Yes,
the
sir.
significance of network command in OSPF and EIGRP?
Yeah, EIGRP is working on the autonomous number,
No,
right? Where
wait. My question is that I'm using on the global mode command router EIGRP1. This command starts EIGRP process. Okay.
right?
And after that, I'm using network command. Correct?
Yeah, network IP and their wildcard.
What is use of network command? This is my question. What
So,
work
To adver-
performed by network
advertise
command?
to advertise the route, mean the which content that router to advertise our network
What is that? What
in the
is
area.
this advertisement do? This is my question.
Actually, I am sharing my network with the neighbor.
How you are saying your network with the name? This is my question. I'm not getting proper answer. Tell me.
Our
Anyone?
network is usually
No. Network command means routing procedure initialized on router's interface.
Oh, okay.
And these interface sends periodic hello message pointing toward neighbor router's interface to update routing information automatically. Okay.
Okay.
Once you are using command router EIGRP1 router OSPF10, it means OSPF EIGRP, we have started the process. After that, what we are using network command means we are forcing router's interface to join a multicast group, send periodic hello messages and update information automatically. So that network command we require. Okay.
Okay, sir. Understood.
So this is dynamic process. So here we are not required this thing. Only required IP router access, that's all. And automatically neighbors set will form without joining multicast group. It is exceptional IGP protocol. It defines neighbor automatically without joining multicast, without
So,
initializing. Yeah,
IS will not share any packet with the neighbor
will
to
share
establish the connection.
it will share layer 2 header protocol data unit information. It will share
Okay.
everything, but uses layer 2 header, not layer 3.
Okay, sir.
Okay. So that we have complete configured on router 1. Now, one option is also available. See, interface F00 ISS circuit type. If Rahul, we doesn't want to advertise, means force ISS protocol, all interfaces to use that particular label, then we have the option to on router's interface, we will use command ISS circuit type. Individually, we can decide this interface in this level, this interface in this level. But once we have mentioned on the router configuration mode ISS type, now automatically all interface join that particular. These 2 points need to remember. One point says what command I have used there. That is router ISS. It doesn't show me that part. Yes, see. Router ISS type level 1. What does this mean? I have forced router 1 F00, F01, F1/0 including loopback. Now your identity is level 1. If we want F00 to be part of level 2, F01, F1/0 will be part of level 1, then individually on the interface mode we have to decide the level. These 2 options available in ISS protocol. All right. Now on router 2, we will use this command. This router ISS NEP 49, we have decided 0256, 4 times 0, 4 times 0, 3 times 0, 2, 0, 0, and what went wrong? Oh, multiple times. IS type label 2 only. Now you can see one thing. Sorry. Here it is clearly mentioned ISS type level 2. Why? Because I am not working on CSR and ASR series. I am having IS image compatible to the ISR. So here it will show you it is level 2 only. This part need to remember. And then same command interface range of 00-1 F1/1 and loopback 1 IP router ISS. That's all. It's very simple. Router 2 completed. Now on router 3. Same thing here. Router ISS NET 490134 4 times 0, 4 times 0, 3 times 0, 3 and 0, 0 type level 1 interface range. On router 1, I have not committed any mistake now. 0134 part. Interface range F00-1 and loopback IP router access. That is router 3. Now router 4. Router access NET 490134 4 times 0 4 times 0 3 times 0 4 0 0 type local 1 interface range F00-1 loopback 1 IP router access. If you will see command now, show IP protocol, what information you have? That is no timer, nothing like this. Maximum path 4. What interfaces we have assigned under access protocol? These are this is on loopback router, router 3 loopback, router 1 loopback. Administrative distance is 115. And default gateway already that is default is 115. That's only information you will receive. So IP interface F0/0. Sorry, F0/0. It is not mentioned here multi-car reserve group join. Yeah, nothing is like this. If I will show you capture part, it's only shows some different part. It will not show you that layer 3 header part, IP header part, nothing. So router 1, 3, 4, 2 completed. Now router 5. Router access NET 490256. Then we have 4 times 0, 4 times 0, 3 times 0, and 5, 0, 0. Level 2 keyword required only interface range F00-1 and loopback 1 IP router. That's all. Finally, router 6 is there. Okay. So on router 6. Yes. Router access NET 490256 correct. 4 times 0, 4 times 0, 3 times 0, and 6, 0, 0. Equal to only interface range F01, F1/1, and loopback. Correct IP router access. That's all we required first thing. Now see, ISS is only protocol which consists two neighbor table, which consists two database table. Multiple options are available here. So see, in this way I'm going to show you. I'm on router 1. See what all output we are going to verify. So ISIS system ID means who is my neighbor, route neighbor name, type, router 2 in L2 label, router 3 and 4 in L1, what interface is connected with the neighbor, IP address of the neighbor, they are up, the time they have formed the neighborship, that is whole time, and circuit ID we have mentioned now. That circuit ID 234.01 means it is formed neighborship with router. Now, another thing we have, if I want to verify the MAC address of the neighbor, so we need to run command show classless network services name. Though it uses level 2 header, but OSPF and ISS only protocol which is 100% classless. 100% classless. So see what it says, system ID as it is interface. Now you don't have the option of IP. Here it says the neighbor MAC address. And then type L2 protocol is ISIS. It is intermediate system to intermediate system. All right. Now, not only this thing. So, ISIS, we have topology. Now, topology says level 1 part 2 database, it is going to have level 1, level 2. And then the metric part means what the ISIS metric is also cost, or SPF metric is also cost. Calculation part is same, 100 Mbps divided by length. We are getting this option if you will see what the sequence number. Show ISIS database. Now it says you sequence number, level switch path checksum, level switch path hold time. That information you will receive here. Next selector is 00, that's why R1.0-0. And then show IP route ISIS. You are having two databases, level 2 and level 1, correct? Now I'm having all route information. 115 is the administrative distance value, and every time it is showing me the multiple cost information. Number of hop is available, 10, 10, 10 is going to add. One moment. All. If I'm going to show you router 2, so IP route ISIS, it consists only level 2, okay? And then if you will see router 3, now you will see here. So IP route ISIS. Now thing is that I means ISIS protocol. It consists default route automatically pointing towards router 1. So now we doesn't have any router 2, 5, 6, their loopback information. But based upon this default route, we can access those. So default route generate automatically. All right. Same on router 4. Default route. And then see, I will show you also one thing here. It's only level 2. Now see, in future, if you are going to plan to give the CCI service point, then they will ask you, this is the level 1. We have default route I star L1, but we want all these information individually. We want those information individually. It is called route leaking. Router 1 consists level 1, level 2. Now, so I want level 2 will come individually along with the default. So that is called route leaking. So here it's very simple part to configure.
Sorry, sir. Sir, can you show me the route of R4 and R5?
See now, here we have router 4. You have
Okay.
default route. And
But
then we have,
we are not getting the route from the 0256, the other area, right?
that's why we have this default route. If you want to ping now, 10.6.6 router 6, source 10.4.4, you are getting reply. How?
But
Because
but in
this
R5, we are getting the route of router 4 and 3.
is at the level 2 now. Why? Because who is ABR right now? Router 1 now? C router 1.
No, yes.
Router 1 consists level 1 10.4, level 1 10.3, and router 1 when it is going to share this information with router 2, that is the level 2 now. It will convert that into level 2. Level 2 understand only level 2, doesn't understand level 1. In
Okay, sir.
form of level 2, they have this access, okay?
Okay, sir.
So look, production environment only level 2. Now my question is that I'm having here only and only default route. I want individual route also on router 3 and 4. So what we require on router 1, how to enable route leaking? I will use command access list 110 format IP any, and then I will use command router access redistribute access IP level 2 into level 1 level 1 distribute list 110. This command we have executed. So run section ISIS. Now, look, I have not configured any route map here. Otherwise, we will use command that is access place 110 permit IP and any router route map, suppose filter or leak format 10 match IP address. Then you will use command route map. If only ACL is there, we are using distribute list. So this part in our CCIE service provider lab part, sometimes they are telling use route map, sometimes they are telling use distribute list. Same part is there. So now this is the part of route leaking. I have distributed level 2 into level 1. So now, if you will see router 3 after that, what output we have? Now you can see we have different area route. You can see I and A. It is the different area route. Okay. I says inter area means different area. One area is L1. And we have default route as well as individual. So this is called Rahul, how we are going to configure route leaking in ISS. Sorry.
Okay.
172 IP. Oh, Abdul, see, a free router. See here. I'm using my IP part 170 to 16 this way. See, this is my basic part always remains 170 to 16 12.0. Obviously, it is 24. I'm going to mention here. Okay, this here. Then router 1 and 3 13. Here I'm having 1 and 4, that is 14. Then router 3 and 4, that is 34. Here, this part having this address. Let me explain. And then it is we have 25, that is 25, and 26 having 26 here 25. Then we are having 26 here, and then we have router 45, that is 56. Fourth octet always router's name. I'm going to show you. See, on router 1, so run interface F00. For loopback, no, for loopback I'm using this address. So run interface loopback 1, that is 10.1.1. Every router having router 1 10.1, router 2 10.2, router 3 10.3. This is my loopback IP. All right. That's why these are the loopbacks. Okay. And these are the connected interfaces we have. And if you will see here, show IP route. Now you can see In ISAR image, you can have two things, connected and local. Local part, it says your entire IP along with the C area 32. That's why it is 34.3. It is 13.3. So this thing is here, okay? Now we are going to understand we know how to configure summarization in EIGRP, in OSPF, in BGP also. Now we are going to learn how to configure summarization in ISS protocol. See, on router 5, we are having these IPs. I'm going to configure certain loopback. Interface loopback 2, suppose 55, 55, 55.0, loopback 3, that is 1, loopback 4, that is 2, and loopback 5, that is 3. So now we have this thing. 55.55.0.123, correct? So what you required? Interface range, loopback 2 to 5, correct? IP, router, ISIS. That's all. First thing we required. Okay. Now if I will show you the router 4 part now. Now we have these individual. Correct? On router 2 also, if you will see, we have these into individual. I want to convert this into one entry. The command syntax is very simple. Everything required label. Like OSPF, either it is summarization, authentication, area ID range is required. Here label is required. Like router access, summary, address, 55, 55, 55.0, 255, 255, 255, entries 252, 023, 4. Then we have to mention label. Here it says level 2. Here it is not telling mention level 2 only. Very typical part. Okay. And that's all. Now see. After that, if you verify router 4. Now we have one entry. Previously it was individual. Okay. Now CRDR 30 and having one entry only. Now cost is going to change dramatically here. It is 168. No need to worry about what the cost is going to show. On router 2, now it says here 20. So this way, we are applying summarization. EIGRP OSPF supports HMAXA authentication. ISIS doesn't support HMAXA authentication. So it supports only MD5 and plain text. Like OSPF also support pre-authentication now. Plain text, MD5 or SAW or none. ISIS says I am supporting only two things, MD5 and plain text. ISIS was the first protocol to inform entire part. If you want to configure that authentication now, first you need to have keychain, key number, the password, then apply on interface. So that is adopted by, as it is in EIGRP, in OSPF also in the cryptographic algorithm part there. So same thing. Between router 2 and 6, I am going to configure, you can say ISIS authentication. So ISIS neighbor. Now neighborship is up. It having neighborship with router 1, 5 and 6. Both are in L. Correct? So now on router 6, use this command. Key type CCIE. Key number between router 2 and 6, lower to upper 206. and key string is password. That is Cisco. This part is here. Okay. Copy this string from here. Apply as it is on router. First one interface, correct? So here interface F1/1. ISIS authentication mode. Now you have the option. IP authentication mode, EIGRPS number command we required in the EIGRP. Here ISIS authentication mode, MD5 or text. I will use here MD5. And then ISIS authentication key -chain, and my keychain name is CCIE. So these two commands are required where? On interface F1/1, correct? Now if you will see here, no authentication failed message is here. So on router 2, if you will see, when it is up, let timer to expire. Now it is in init state. Means synchronization is not there. So interface F1/1, apply same parameter here, and they will form the neighbor cell. So this way, we are applying authentication in ISIS protocol. So ISIS neighbor. Now see neighbor set is up. Is this good? Little
Yes, sir.
bit? Yes,
Yeah.
no? All right. This is the part we need to apply how to configure ISIS in IP version 4. How to configure ISIS in IP version 6. See the syntax this way. I am on router 1. I will copy only this thing. To run section ISIS. We'll use command router ISIS. I required any NSAP address. We need to use command metric. Why we required to run this command metric style white? IP version 4 scale is 632. If I will change scale from 32 to 64, then routing information base will convert to 128 and it will automatically support IP version 6. Once you will configure EIGRP in name mode now, you will find same thing. Metric version 64 and range scale is 128. That pattern they have copied from here. Now, address family IPv6. What option it says? Unicast. And then multi topology. Means at a time, I'm going to support IP version 4, IP version 6. So we require this thing. First, we required metric style white under address family IPv6 multi topology. After that, interface range F0/0-1 and we have F1/0, loopback 1. Command is IPv6 router ISIS. We have not IP router ISIS. We need to enable these two things, IPv6 router ISIS. Okay. So see here, what we required. First, get this part. Show run section and SAP address is required for both. I will use command router ISIS. I will copy and SAP address here. Then I will use command matrix style void address family IPv6 unicast multi topology interface range of 00-1 f1/1 comma loopback 1 IPv6 router access. After some time, if you run command now, so IPv6 route access, it will take some time. Now you can see. Here it says I2 level 2 and we are having router information via link local address. So this command is required. What command? Multi matrix style void. So IP protocol and it is not showing anything if you will capture. Okay, let's configure everywhere. We will verify the part. So router 3 again, what you required? Run section ISIS. After that, router ISIS. This NET is here. First command, matrix style void address family IPv6 unicast multi topology interface range F00-1 loopback 1 IPv6 router ISIS. Okay. So three parties here now. Let verify here. Try to capture. Intermediate system, hello, this information you will get ISO intra-domain routing information exchange protocol and ISIS hello circuit type level 1 and 2. Resolve this part, system ID, protocol supported. What it says, the protocol supported means type 129 LPD area of concept ID is part. Interface address, that is 12.1. IPv6 interface address. We are having this information, link local part, multi-topology part is there. IPv4 unicast, IP restart signaling padding, this part you will get. You will not get anything like in the IP header part, any information about what it is there. We have inter-domain routing protocol discriminator, ISIS, length identifier, version protocol ID extension, reserve, and maximum area address, that is 0. That only thing you will get. Not any IP header information. CCNP v6 header part is here. FF02 directly connected part. So we are, but I'm not getting that information. Come. Here you will get this information. See. It is the payload path. This is the IPv6 header information. And ICMP v6 part is here. This information you will get. You are not having any protocol option here. Traffic class, payload, next header, ICMP v6 header 58 part is here. But no IPv4 header part for anything. So this way ISIS protocol is going to work. All right. Little
Yes, sir.
bit fine. Fine now. So now same part we required on out of 4, 5, 6. So ISIS will complete configured in IPv6. Only thing my part is that try to do some basic practical of ISIS. Rest document I have shared. That will help you a lot to understand the fundamentals. And we required those things.
Do you have any scenario topology? I mean, scenario-based topology for ISIS?
This is only thing.
This is the only one.
Yeah, as doesn't we required more
Okay.
because in ACI part, ISIS remains enabled by default. In DNAC, we need to run only click the option ISIS, rest automatically going to configure. Yes, once you will configure ISIS protocol manually in ISP's domain now, yeah, there only we required only one level, that is level. It's very simple
Hmm,
part to
for
obtain.
example, do you have any LLD? I mean, low-level diagram, so we can prefer and create a topology in our system.
Uh, which part you are using? If you are using EVNG software or you are using
Both,
that.
both, sir, both.
So draw this diagram, that's the only thing. If you want, verify everything. Nothing is required for ISIS. Only thing how to establish the connectivity and how we are getting access the route. So use this topology, draw this topology using this
Okay,
version of router. That is better to use 70 to 100 part. Otherwise, with the EVNG part configure, that's the same thing. And but that is only part, nothing we require. This is the
okay,
only
sir.
topology we require there, and that will help you to understand lot of things. Okay.
Okay, okay, sir. Thank you.
Whatever thing, welcome G. What about both of you? A little bit, this part is good, little bit. Yes or no? Say something. If you have any query, anything now, let me know. Mention in the chat window. Then we have finished this part. We will understand some fundamental of MPLS part. I will show you how that is going to work. Two things I will show you, basic configuration, and then I will show you the part you can say how to configure different protocol under MPLS part, that will over. And then multicast we need to understand. And quality of service. So both of you tell me, access little bit good to you? Is this part clear? Any question, any part, let me know. Unmute yourself and tell me. No reply. Okay. We have time. So first I want to share you something so that you will read a lot here. And that is here. Okay. Section now. This part is good. So if you have the time, go through. This document will help you. In my CCIE document, I am having MPLS PPT. Entire thing I am giving you. A1 and the best PPT I've got from the Cisco. This part I am telling you. And in Airtel Bharti training was there. I delivered the training, so I informed them I doesn't have the time. So they have provided me this PPT, and I kept that part. It's very good to understand each and everything. That was my first type of corporate training at that time. Okay. You will read that part. I will explain you lots of things here. Okay. So see, let me open basic diagram. First, I will explain PLS.
Sir, are you using GNSC without VM?
GNS, I have not integrated VM in EVNG, I am using VM.
Okay.
Here I am using iOS. And if you will see my EVNG partner, there I am using virtual iOS. Okay.
Yes, sir. Yes, sir.
Here is multiple protocol level switching. What actually MPLS is? In 1990s, Cisco recognized one major part in BGP thing. That now try to give me the answer. If I'm going to draw a diagram that this is one ISP, this is one ISP, and this is one ISP. Here I am having router 1, router 2, router 3, and router 4. They are connected in this way. Between them, I am running OSPF protocol. Then here we are having router 5. It is connected with router 1. They are external BGP neighbor. Router 6 connected with router 3. They are external BGP neighbor. Forget about the S number, doesn't matter right now. We need to focus on what we actually want to achieve here. Now Cisco find one thing. Because router 1 and 3 can form a BGP neighborship via loopback. Router need not to be connected directly. If we have reachability, any two router form BGP neighborship. That's we are aware with this part of BGP using loopback interface, update source loopback 1. In external part, we have external BGP, BGP multi-hop or TTL security. Fine, both things are common. Fine, same. Now, when router 5 will receive router 6 information, it will try to access router 6. Request will receive by router 1. How router 1 will share this part with router 3? Because on router 2 and 4, we are not having any BGP. It's not possible to have BGP to SPF distribution. SPF maximum can handle 50,000 route. GRP 2, 3, 4 lakhs. It is not possible. So practically without VRF now, OSPF BGP, we are not applying this IGP to EGP, EGP to IGP distribution. That is not the way. Then two options left, either to configure BGP on router 2 and 4 or have physical link connectivity between router 1 and 3. That was the only solution. So in 1990, Cisco developed one mechanism that is called tag switching. Tag switching means using label information. Route lookup is not going to apply on router 2 and 4, will not ask router 2 and 4 to do the route lookup. Neither they are going to have BGP route in their table via distribution, but still they will carry BGP. So that is called MPLS to make ISP score BGP free. That purpose they created MPLS. So, and then all vendor requested to INA and ITF that if Cisco will make this proprietary, how we will survive. In 1990, stack switching convert into MPLS. Ultimate purpose is that without having route, without doing distribution, using label part, end-to-end communication work on IGP based upon the IGP table. Now we are creating our separate table for the MPLS part, forwarding table, label distribution protocol, binding table, and we are getting end-to-end connect. So first purpose was to make ISP score BGP free. So see here. Now you can see on router 1 linked with router 7 and router 8, they are external BGP name, correct? Router 2 with 9 and 10, they are external BGP enable. And router 1 and 2 are internal BGP enable. Here I am running OSPF. But router 1 to 2, we have router 3, router 4, router 5, router 6. So it's not possible to configure BGP on router 3, 4, 5, 6. Neither we required. So where we will configure Outlook up? On router 1 and on router 2. So they will inform router 3, router 1 will inform router 3, certain label I am going to say. Based upon that label, you will carry and forward information towards next P route. So this network domain, without having any BGP, using label part, they will carry your what? BGP route. So route lookup occurs here. So where MPLS label is going to attach between layer 2 header and layer 3 header. So this we say layer 3 header and layer 2 header. That's why MPLS is called layer 2.5 technology. This is the part of MPLS. It's called layer 2.5 technology. Because if every router is going to have 1 lakhs route and they are going to do the route lookup, it takes too much time to carry and forward customer requirement for one end to another end. So here we have three set of router: provider edge connected with customer edge router, provider edge connected with customer edge router, and provider edge also connected with provider router. So between provider edge and provider part here, till this particular part, we are going to configure IGP, and applying based upon the IGP table, we are creating MPLS part. So this is called your MPLS. Okay. Then, which protocol understand MPLS part? So two protocol. First protocol was TDP, Tag Distribution Protocol. Now Cisco is not supporting like ISL. Label Distribution Protocol. We are generating label. Then we have Border Gateway Protocol and Resource Reservation Protocol. These four protocol, out of which two protocol generate label, they understand and carry label. This RSVP is the part of int-serve type of RASP US mechanism where we are applying traffic engineering. So this part we have. Okay. So now I'm going to show you something. You will try to read. Drawbacks of traditional routing. MPLS features. ATM is not supported by Cisco after 2014. Traffic engineering architecture, component labels, label switch router function, this part. So traditional routing protocol distribute layer 3 routing information, forwarding based upon destination address, route lookup are performed on every hop. What do you mean by route lookup, Rahul? What is route lookup?
Route lookup.
Hmm.
I forgot that word.
Route lookup means, Rahul, source address is going to carry everywhere, destination address to verify on every hub.
Oh,
The number
so
of
this
router remains source address carry everywhere, destination address need to verify on every hub. That is called route lookup. Okay.
Yes,
And
okay.
this is called basic routing and it is destination address based. Once I will explain you the multicast, this point will again come into picture. What is unicast routing, what is multicast routing, what the difference we have there. So route lookup means every hop source address is going to carry, destination address is going to verify. If you have 100 router and every 100 router is having 2 lakhs route, it will take too much time. That's why we doesn't want to apply configure BGP on every router. We will force them. Route lookup applies only on P router and you will carry BGP route without having BGP route in your routing table. So only do the label lookup, not the route lookup. This way MPLS works. So here it says that every router may need full internet routing information more than 1 lakhs route. And destination based route to completed on every hop. What is destination based? Source is carry, destination is going to verify. Hopping execute when source consists destination address and destination consists source address. The number of hop we have between source and destination. Everywhere this information need to be in the routing table. They will do the route lookup, then end-to-end communication established. This creates lots of delay and loss. And layer 2 device doesn't have this particular knowledge. And then policy-based routing every time is not going to work. It has certain limitation. Every part is not possible to will apply policy-based routing. So what we require is a new forwarding mechanism which packets are forwarded based upon the label. Or usually corresponding IP destination network equal to destination IP forwarding. We are attaching a label on it. It also uses other parameter along with the quality of service and designed to support all other protocol. Whatever the WAN protocol we have, it is going to support. So only edge router perform the route lookup, like P router. Now we have one term is here. Layer 2 devices are IP aware and run a routing protocol. Means when layer 3 switches we are using IP routing and applying routing. And MPLS provides virtual full mesh topology. So now MPLS uses two components, control plane and data plane. Control plane means which carries layer 3 information. Insert destination address route and generate signal on source route. And data plane, control plane consists entire topology. And data plane verifies next hop as per instruction received from your what? Control plane. So here TDP, LDP, BGP, here all are the routing protocol or control plane. And label forwarding information base is the data that is mentioned. SPF LDP label distribution protocol control plane. Label forwarding information base is the data. And then MPLS header that is a 32-bit. 20 bit is for label. 3 bit for experimental that is quality of service. 1 bit is the bottom stack and 8 bit for TTL. So this is called your MPLS header. Like we have EIGRP header, SPF header, BGP header now, frame header, LLC header, TCP header, same thing is here. So MPLS level is 32-bit, 20-bit is for label, out of which 0 to 15 remains reserved. From 16 next to the label comes automatically. 3 bit is for quality of service part. 1 bit means which is the last label attached by the protocol. And 8 bit is TTL bit, so unnecessary packet is not going to roam. Once TTL come to 1, it will drop the request. To avoid loop, that is called time TD. Then here you have multiple things here. Where MPLS label inserted, label format, label stack, forwarding. Label inserted between layer 2 frame header and layer 3 header. That's why already mentioned now. It is called level 2.5 technology. Multiple level we have. Bottom stack means last level in the level stack. TTL failed to prevent indefinite loop and experimental bit for quality of service. IP precedence value. Quality of service part we will discuss. And this already we have gone through the part. And then basically one level is assigned. MPLS BPN. Here BPN once BPN except for the IPsec part doesn't means we are having encryption. Means two private network is going to communicate with each other. Different per location network is going to communicate. That part comes under BPN. Same VPN terminology in different way you will learn in the SD-WAN. Then we have VPN different fundamental we have in the VXLAN, Ethernet eVPN, L2 VPN. So multiple things we have there. Then traffic engineering, 2 and more level, MPLS VPN along with traffic engineering, 3 and more level we have. And the router, where label generated and their shared label, that is called label switch router. And their path is called label switch path. So how this is work, I will show you. So see here. Once this router 7 and 10 are in the same color, in the same, you can say, AS number, correct? Same for router 8 and router 9. Same AS, same color. If they want to access, it will receive information if it is moving from here to this part. Forward this information to router 3, it will insert label there. Then router 3 will receive label, swap label. So router 3 to 4 to 5 to 6 label will swap. After that, router 6, we don't have any PE router. It will share information to PE. That is called pop tag. So router 6 will inform router 2. After that, you are connected with customer. So you will keep label with yourself. Once you will share information with customer, without label information need to be shared. So that is called also penultimate hop popping. Penultimate hop popping. No need to do the route lookup multiple times. So these are the certain thing that is called insert label, swap label, and pop tag. This way this technology works. So these are called LSR route, label switch route. Label switch router, these are also label switch router. This part is called label switch path. So these are called edge LSR. Why? It will receive request, it will forward request, ingress, egress, egress, ingress. Depend upon how they are going to. So these are the certain thing we need to remember. One part, that is the one section of MPLS. Now, which router in the production environment we are using in P? These are called ASR. And these router consist line card. One line card, suppose we are having 3 line card in one ASR and 2 soup engine. A small part I am telling you. 3 to 4 line card and 2 supervisor engine, one will fail, another will work. Soup engine is called. One line card having, suppose 20 SFP means 20 interface. So 3 part having 60 interface, 4 part having 80 interface, 5 card having 100 interface. Means,
This is a chassis also.
yeah, chassis based router. Yeah, all ASR are chassis based, all CSR are chassis based. Okay.
Okay, sir.
And rack mount are the LSR. ISR router are the rack. And these ASR comes into 4 rack unit, 8 rack unit, depend upon how big this router are. So now understand, if in one ASR router I am having suppose 80 interface, it means 80 customer I can have. All customer required MPBG, multiple protocol BGP, that is the MPLS circuit they require. It means I need 80 public IP. It is not possible in IP version 4 to have this number of addresses. No way. So how this is going to work? With the help of VRF, virtual or VPN routing forwarding instance. So your VRF consists, its range is 2 raised to the power 64. That's why separated through column. It having 2 subparts. Route distinguisher, route target. Route distinguisher means, so now you can see here, router 1 F01 F1/0, router 2 part, I am applying same IP without overlapping. So route distinguisher make ISP router interface globally unique, separate instance. We have 2 raised to the power 64 instance. Same public IP configured on all interfaces without having any overlapping. And the route target value, we have two terms in route target. That is export, what information VRF is going to share with BGP, and then we have import, what information BGP is going to share with VRF. So this function is the integral part of your MPLS. So once MPLS comes into picture, it means obviously on the PE router, we are having multiple customer support. One customer means one public IP. If I am having 100 customers, I am in the 5-line card ASR router. 100 customer is there. If 100 customer is there, so we doesn't need to have 100 public IP. So in that particular part, one IP assigned on everywhere using separate route distinguisher part, separate global unicast routing table will come. And if they have separate instance, no overlap will come. And then if I am supporting 100 customer, so one customer identity not exchanged with another customer, in that particular case, what we required? We required BGP using export and import part. They are creating their separate identity. So this way it is going to work. So rule says between two P router, RD value is locally significant and RT need to common between two P. If RT is going to different, no, route will not exchange. So that is called MPLS route leaking. I will show you this particular part using MPLS route leaking. The thing is that how we are going to configure this particular part. Unique identity, multiple address family need to work together, and then that part will work. So my suggestion to all of you, what you will do, first, second, third, and seventh step switching, you will read this slide. Practically, I will explain multiple things how it is going to work. So next Saturday and Sunday, we will understand and will complete your MPLS fundamental. Accordingly, we will move toward the multicast. That also we need to have complete command. All right, so go through the recording and read the particular slide which I mentioned you, and we will be able to understand each and everything practically step by step. Okay?
Okay, sir.
So next Saturday we will meet you. Thank you.